Okay, so picking up where we left off then, it is very important, it really in new construction commissioning, where the commissioning authority starts in the process. If we can start in design, not only do we for us to be involved early is important for our overall performance and success, because it gives us a much better chance of really learning, you know, the intent of the design, the owner's needs, you know, why is this or that incorporated into design, and then also when we walk into the building, if we've been through the design process, it's all going to look very familiar as soon as it's being constructed. Versus if we had no part in the design, no communication with the design team during design, no cooperation there, and we're just asked to come into the building, like say a few weeks before it's intended to be turned over to the owner, we got a lot of groundwork to do to even understand, you know, how is this building supposed to operate, what are these systems, that kind of thing. So, but of course, it costs more to involve commissioning from early on, and so sometimes it's a cost savings measure to try to bring them in as late as possible. But it's not recommended. You know, LEED is really trying to drive. You know, they have requirements in their fundamental commissioning and enhanced commissioning that will drive for earlier involvement in the commissioning authority.
I'm sorry, but it makes more sense. I mean, you kind of said, well, it could be a cost-saving measure to invite them in late, but in the big scheme of things, you'd probably save yourself a lot of time and trouble by inviting them in early.
Possibly, yeah. Certainly, even if it costs you a little more, you're going to get a lot better, you know, commissioning process, and hopefully that means fewer issues after.
Well, it's so much easier to circumvent issues if you catch them early.
That's right. Yeah, we try to catch a lot of issues during the design process.
Sure.
If we can catch it as an issue when it's just an issue on paper before it becomes an issue in, you know, hard piping or whatever, that's valuable. So in existing buildings, you know, just again a little more differentiation of these three different subcontexts. So existing building commissioning, there's generally a focus on improving performance. I say performance rather than efficiency because it's not only about energy. It might be performance in terms of occupant comfort, air quality, occupant health, but very likely also has to do with energy efficiency. And we're often reevaluating the design intent. In retro commissioning, again, it's by that definition, it's never before been commissioned. And some people will perceive that as, okay, then our goal is to achieve the original design intent. Again, I think that's questionable. And then recommissioning, if it's a previously commissioned building, in some cases people interpret that as, okay, we're going to go in, it's been commissioned before, we'll go dig up the old commissioning report, we'll find their test forms, and we'll just conduct the same tests that they did in the first commissioning. Mm-hmm. That may be an okay way to proceed, but I would recommend, especially if you weren't the person who did the original commissioning, which is often the case. I've done quite a few recommissionings of buildings that somebody else commissioned the first time. I'm at least going to look at their tests and say, well, is this how I would test these systems? And also what has changed in between then and now. So, okay, so what is the purpose? What are the goals? Certainly to make the building work better, to increase energy efficiency. Well, you know, make the building work better. That's a pretty broad brushstroke there. Again, that's occupant comfort, indoor environmental quality, all kinds of things embedded in that. To deliver the building that the owner wanted or asked for, especially in the new construction context. To decrease maintenance requirements. You know, sometimes we see things, especially again if we're involved in design, where we can advise a change in the design that will result in less maintenance burden for the owner in the long term. Improving the building documentation, the O&Ms, operation and maintenance manuals, the as-built drawing documents, the systems manuals. Systems manual is kind of a new document that is in some ways like the O&M, but in a lot of ways different, that never really existed until commissioning saw the need to create something additional and designed the concept of the systems manual.
Well, my goodness, you can't buy a CD player without it coming with a stack of an instructional manual like this.
Yeah.
If you're going to build a building, it makes good sense to bring an instruction manual with you.
Exactly, thank you. We need to get you hired on as a sales guy, Brian.
Well, I'm sorry, but I mean,
being honest, you're bringing
in
up
a lot of ways,
yeah.
this is like, it's almost like horse sense 101.
Yeah. And then to improve or provide operations and maintenance training. That's, again, a big part of our, that's a part of the commissioning process that I put a lot of stock in, and I take it pretty seriously.
Mm-hmm.
I've seen a lot of owner trainings following a construction project that were not handled very well, and it's disappointing. You know, I've observed some of those trainings happen, and I've walked away thinking, if I were the building operator or owner, I would come away from that with very little useful knowledge and ability to operate this building. And it's not, I'm not trying to harp on or criticize, you know, the individuals who are providing that training. Of course, I'm not naming names, and I don't even have I've got a number of instances in mind, but it's largely just because it's difficult to do. And it often requires more time and budget than is allowed.
Do you mean to make that transition?
Do it well, to do the training really well as well.
Yeah, yeah. Well, but there needs to be a continuity there. I mean, that transition is really, really important, I would think.
So specific to new construction commissioning, a few other, so these bullet points above kind of apply for existing building and new construction commissioning. And these three below are maybe more specific to new construction. There are ways that commissioning can improve the design bid build process. Design bid build meaning being differentiated from design build, where there's a little more continuity between the design team and the construction team. Sometimes it's the same contractor, same organization, or at least a very tightly knit team, versus the design bid build process where, and this isn't entirely fair, but this is sort of the stereotype, the designers design the building. When that bid package goes out to the bid pool, they are basically done and walk on and they go to the next job. And then, and so there's not a lot of interaction between the designers and the people who are providing bids on the design, on the bid package, who are interpreting those schematics and then putting forth their submittals for different equipment and materials and their cost estimates and all that kind of thing, their bids. And then when they go out and build, they may not have any interaction with the people who designed that. So commissioning can kind of bridge that gap, especially if we were involved in design and then we continue to be involved through construction. Hopefully we reduce or eliminate, well, you probably never would eliminate change orders, but if we can reduce the number of change orders, mainly by catching things in design that we think might lead to change orders, or reviewing the bid package or the spec. But also there's a certain amount of that happens just in cooperating with the installing contractors on the job site. You know, sometimes when they're faced with something that looks like a bunch of extra work for them that they didn't include in their bid, sometimes we can see that it's really not, and maybe they're misinterpreting what has to happen, and we can help guide them to a solution that doesn't require so much more of their time and effort that they have to submit a change order, and you know, owners don't like change orders. So, and then ultimately to eliminate or let's say reduce callbacks during the first year in the warranty period after occupancy. Hopefully the building runs better, and there are fewer issues and fewer reasons for the contractors, the installing contractors, to have to come back and resolve issues. What systems do we commission? So what's typically in our scope? Wow. Well, Zandy says he doesn't have audio. Oh, shoot.
Oh.
Thanks, Zandy.
Oh, shit.
Okay. Well, you got it. So, most commonly, the commissioning scope includes the mechanical systems, the HVAC systems, and the associated controls. Then that's the biggest piece of our scope generally. And then what may be added into that is the electrical, plumbing. If it's not just mechanical, it's usually MEP, mechanical, electrical, plumbing. Fire life safety is sometimes included, but often that's handled by other authorities who oversee and inspect those systems. It can include specialty systems like security, communications, solar, renewable energy systems. Could also include, like your backup generator systems. And I guess what it listed there is a non-typical category. Really anything with a motor, anything that has a sequence of operation, we could commission it. We might have to do a little homework ourselves beforehand, but. So what are the phases of this process? So you break it down firstly into three major categories: the design phase, the construction phase, and then the occupancy phase. Within the design phase, the kind of major process elements are helping to develop that owner's project requirements document and the basis and design document. So ideally, the commissioning authority may help guide the owner through producing the OPR. Ideally, we want that to be a document the owner produces because it is their statement of what they need in their building project. But we can help guide them through that. And then the basis of design is generally created by the design team, the architects and the engineers, and we will review that and provide some feedback. And we're reviewing it largely to see that the BOD aligns with the OPR, that the design is intending to deliver what the owner is asking for. We conduct our own design reviews, so we'll submit our design review comments to the architects and engineers, mainly on on the systems within our scope, like mechanical, electrical, plumbing, and maybe beyond that. Almost always submit some kind of a commissioning plan that spells out our process, our scope, our schedule. Submit that to the project team and the owner. We prefer to be contracted by the owner rather than by the architect or the engineers, as a third party who's looking out for the owner's best interest, and because ultimately it's, again, we're trying to ensure that the building that they are going to occupy and operate is the building they wanted, that they asked for, and it's working as well as it possibly can for them. But that, even when we're contracted by the owner, we do a lot of direct, there's a lot of direct communication interaction with the design team and the construction team. And we're generally just reporting to the owner at intervals. Here's what's gone on in the last week or 2 weeks or the last 2 days, even sometimes, in terms of what our process has been, what interactions we've had with the design and construction teams, what issues we found, what issues have been resolved, those kinds of things.
So there's a little diplomacy involved too?
Oh, sometimes, yeah.
Kind of,
which is generally not too difficult. I mean, you try to just remain an objective third party as much as possible.
Yeah, just keep the lines of communication open.
Yeah. And so in the construction phase, we might update that. If we submitted a draft commissioning plan in the design phase, once we get into the construction phase, some things may have changed. We may have learned more about this building and this design and this construction process. There may be some changes to put, that the commissioning plan is very much a living document, so it can be updated and resubmitted. We'll do submittal reviews, so when the contractor's submittals start rolling in based on, again, on their interpretation of the bid package, we will review their submittals and compare them to this project specification and help decide is what they're submitting in terms of equipment, materials, et cetera, is that aligning with the specification. Also helps us, it's another step in the process for us of learning the design and learning, everything there is to know about this building project. Then we'll start doing, once construction's ongoing, we'll start doing site walks at regular intervals to try to catch any mistakes that are happening in terms of the installation and construction. When the major, again, typically the HVAC equipment, when the major equipment pieces start showing up on site, like boilers, big air handlers, and those systems are installed and ready to be started up for the very first time, we generally try to get there before the scheduled startup time, go through a checklist to make sure it really is ready for startup. There are no missing parts or pieces, or nothing's installed improperly. And then whether we are sort of orchestrating the startup or whether they have a factory technician who's coming to do a factory startup on those systems, will be there to oversee that and to document that. We'll work with controls contractors to do point-to-point testing, which is just making sure that the thermostat in this room is actually communicating with the unit that serves this room, versus sometimes you'll have the thermostat in this room is controlling the unit in the next room, and that doesn't work very well, right? So things like that. And then functional performance testing, which is really testing those systems to make sure they actually operate according to the sequence of operation that was written. And again, we might be testing the system and reading the design sequence of operation, and at times we may say, you know, I see how this was written, made sense at the time, or I see why they went this direction, but I think there's a better way to do this. And we go to the designer, you know, maybe it's the design engineer, mechanical engineer, and say, look, you know, I think you wrote this sequence. I'm advising that maybe we change this aspect of it, and if they approve, then we go work with the controls contractor or the mechanical contractor to make that change happen, and then retest to make sure that it is working as well as it can. Meanwhile, through all this process, we maintain, as I said, what might be called an observation log, or a deficiency log, or issues log. Observation log is just a sort of more diplomatic terminology that also because it isn't necessarily a list of only issues and deficiencies. It may have questions, it may just have observations that help sort of orient everybody in terms of the status of the project and how construction is progressing. And then we will review the operations and maintenance manuals, IONMs, and then do either, you know, sometimes we're just observing training, sometimes we're delivering the training, sometimes it's a cooperative effort between installing contractors and commissioning, but it depends on what the contract says. But one way or another, we're involved in the occupant and owner training. And then in the occupancy phase, ideally we come back and do some seasonal testing or some post-occupancy testing. So if we did all our commissioning work in the summer, when all the air conditioning systems or cooling systems are working, and we haven't had a chance to test the boilers or the heating systems, we'll come back in the fall or the winter and test those systems out. But also, even if it's not a seasonal issue, you know, it is good to come back after the occupants have moved in and started, you know, occupying the building and see how things are working. Get some, you know, talk to some occupants or do a survey or some way or another find out how it's working for them.
Absolutely.
You know, LEED requires a 10-month post-occupancy commissioning review, and at that point we can also do, you know, inevitably there are some issues that hit that observation log that never did get fully resolved, and it's a chance to go back and see if they've since been resolved, and then submit a final commissioning report that basically details our entire process from beginning to end, including all our test forms for when we tested the equipment, copies of equipment startup forms, point-to-point testing reports, all that stuff. Okay. Technologies. So there are some construction management and commissioning software tools out there. I haven't, I've played around with some of them, but haven't really implemented any into my process. Some of them are very expensive, and that's been part of the reason that I haven't adopted those. But for the most part, I find my way with my own custom spreadsheets and, you know, documents that I create, test forms that I write from scratch and things like that.
That's not your house, is it?
That is my house, actually. So,
okay.
In terms of field measurements, you know, there are a lot of metering and measurement tools that we use to measure airflows, pressures, temperatures. Sometimes if we're doing envelope commissioning, we're using infrared camera kind of diagnostics, like we've done some of when we did our blower door testing. Might be doing sound measurements if the scope calls for that. Might be doing some power quality, or energy measurements, along with some others that I haven't listed there. Diagnostic monitoring is kind of what we do either with data loggers that we've deployed, or using the building automation system and its trending functions to be able to watch parameters associated with system operation over time, and to further verify whether your systems are, you know, sometimes when you go do a functional test, you're there with one given system for anywhere from an hour to a couple days, you're still just seeing a snapshot. You know, you're watching the operation of that system within a short duration of time. You're doing your best to simulate varying conditions of operation, to try to simulate, okay, what is the system going to do when it is the coldest day of the year? Let me make it think it's the coldest day of the year and see what it does, right? But that only goes so far. And some things, some issues, for instance, are much more apparent when you look at a longer trend of operations. So we do a certain amount of that.
Yeah.
So, we're working a lot with the building automation system, we're using that interface to test the systems and observe operation, as well as commissioning the interface itself. So I'm looking at the graphics and I'm saying, okay, are all these labels correct? Are all the, if they've got a temperature sensor on this panel, why isn't the temp shown there? Things like that, right? So I'm commissioning the interface as well to know that when the owner starts using that interface, it's as accurate and complete as it can be, and user-friendly as it can be. But here's just an example of a trend data that I might be looking at to assess whether that system is operating as it should. Is the system turning off at night? Is the modulation of some certain valve or damp or smooth? Is the temperature being maintained where it's supposed to be, etc. Let's see, where are we now? Next part. Not quite, go a little further. So we find issues at all the different stages of the process: design, construction, acceptance, which is kind of the testing phase, and post-occupancy. Design phase issues, these can be poor coordination between trades, meaning the design is setting up for coordination issues. So we might look at the design documents and we're looking at a plumbing page and a mechanical page and see that there's some plumbing piping that runs right into a duct on the mechanical page. Something like that. Mm-hmm. Just simple drafting errors, incomplete or erroneous sequences of operations, conflicts between the drawings and the specs, conflicts between the specs and the submittals. That's really more in the bid, after the bid package goes out there, so a little bit at the end of the design phase. Lack of good internal QA, QC by the design team. It'll be things like, we might look at the set of drawings and say, you've got this system that's in the design, it shows up in the floor plans, it's a fairly complicated system. There really should be a detail, like a blown up detail for the installing contractor that shows the more intricate details of the piping than what can be seen in the floor plan. And it's not here now, can we have a detail on that? Or we're looking at a detail and saying, thanks for the detail, but I think it needs to be revised a little bit. This doesn't seem quite right. Lots of stuff to look at in design. In the construction phase, again, poor coordination between trades, misunderstandings of design. Again, it's just a schematic. It's all schematics are subject to somebody's interpretation. Design documents are conceptual. Equipment installation issues. So this is something we see fairly often. The manufacturer has some very specific instructions about how this system needs to be installed to operate properly. Right. Sometimes the design engineer has created their own detail that's different than the manufacturer detail, and then the question comes up, well, which detail do I follow? Other times the design engineer did not come up with a detail. The installing contractor may just have not bothered to go look at any details, whether they were from the design engineer or the manufacturer, and they're just doing it their way, the way that they think is right, and it may not be. And then ignoring identified issues. So not uncommon that an installing contractor or a GC who's under a lot of pressure in terms of schedule and budget, they know there's an issue there. It's not high on their priority list. They move on to the next thing, and they take long before they've completely forgotten about it, and it just gets left.
Yeah.
Or again, issues. There's at some point their understanding and knowledge starts to drop off when we get into systems level stuff, systems operation. They may have a hunch that there's an issue, but they just don't understand what the issue exactly is, why the issue is happening, etc.
Right. The intricacies might be eluding them.
Yeah. In the acceptance phase or the testing phase, one of the first things that comes up is that the GC or the superintendent calls us and says, okay, we're ready for you to test this system, and then we show up and it's not even fully installed.
Mm-hmm. Well, again, I think that there's so many details to any specified discipline that, anybody who's not well entrenched in the loop is gonna miss on those fine details.
Very possibly, yeah, exactly. Or, we may show up and find that the installing contractors are not ready for the test. They're not there. They don't show up, or they have other plans for the day or whatever. We find conflicts with other trades in the area of the test. So, the mechanical contractor who installed the boilers, let's see, what's a good example? Okay, they're totally ready to, their boilers and their heating hot water system is set up, but there's supposed to be some integration. The boilers are supposed to be able to create domestic hot water through some sidearm heating, and the plumbers haven't finished their domestic hot water system piping or something like that.
Sure. Right.
Again, ignoring previously identified issues, unauthorized changes to sequence of operations. So this is very common. It's, just the controls contractor, just like a lot of the contractors who install the mechanical systems or other parts and pieces, they often will think, well, I have my way of doing this, and I didn't bother to read the design engineer's schematic or sequence of operations. I know how this is supposed to work. And sometimes they're right. Sometimes they do have the better way, but there still needs to be some coordination, some discussion, some approval, and so we help make that happen. And then coordination with external parties like utilities. Seen enough of that. Getting behind schedule. There was lack of sufficient time to execute final testing procedures. So, the heating hot water system is finished a week before the owner is supposed to move in, and the owner doesn't want us in there testing when they're moving in, and so what do? We have to watch out for that. Okay. Post-occupancy issues. Good reason for seasonal testing is the new season brings issues that weren't detected during the season when you were doing the testing. If you're testing in the summer, you might not catch heating issues, vice versa. Occupants don't use the building as expected. The design, and a lot of assumptions that are made in design and construction about how the occupants are going to use certain spaces or certain equipment, and then they move in and you find out that they're doing something very different. And in a lot of cases, you can't tell the occupants to do otherwise. It's their building, right? And so you have to find ways to adapt and make the systems work for the different way that they're using them. Operators don't operate the building as trained or expected, and they're just the impacts of time, nature, things falling out of calibration, degrading over time, wearing out, a lot of things in, if a motor is going to fail, talking about bigger three-phase motors, it's either going to fail, a few weeks after it first gets started up, or a few years under normal circumstances, or hopefully 10, 15, 20 years. But if it's a bad motor, if it has an internal short that it develops because of some factory default, you're going to know that pretty quickly. So you come back for seasonal testing, you'll catch things like that. Lemons. Okay, let's see, now it's probably time to switch.